Hi everyone. In this video, we are going to do some examples to calculate areas of different shapes in Unit 2 geometry homework. And this is just some examples. Let's get started. Let's look at the first one. We do this one by one. The first one, find the area of circle with a diameter of 9 yards. Round to the nearest hundredth. That means in the final answer, you should have 2 decimal digits. And first of all, we need to identify the correct formula. We are doing the area of circle, which has formula A. A represents the area, pi r square. R represents radius. But we are given the diameter of the circle, right? Diameter is total length from one side of circle to the other side through the center. So this is called diameter. Apparently, from the center of the circle to the edge, this is called a radius. So we only need half of the diameter to get our radius in the formula. So first of all, we figure out the correct radius, which is half times 9. This is a 4.5 yards. This is the number we are going to use. And now we plug in numbers into the formula. Keep in mind, unless in the homework description it says use 3.14 for pi, you don't want to use 3.14. You want to use the full pi. If you don't know how to do full pi on your calculator, at least you need to write down like 6, 8 decimal digits. The reason is if you use 3.14 instead of the full pi, you will have some truncation error because 3.14 is just is approximation of the real thing pi. When you have truncation error, that error will be multiplied by r squared. That means that error will be exaggerated by many times. You're going to be outside that the range of 0.5% on your homework. Okay, times 4.5 square. So now let's use the calculator. Pi times 4.5 square. So I got 63.617. So I only need to write down 3 decimal digits because I need to round it to the 100th place, which represents 2 decimal digits. Since the third decimal digit is a 7, which is 5 or larger than 5, then you will round this digit up. This is in second decimal digit, second place. So the final answer is 63.62. And don't forget the units, square yards. In the homework, on the Blackboard homework, you only need to put in this number without units. Okay. And this is our first one. Now let's look at the second one. Find the area of circle with a radius of 17 yards around the 100th. Now this time we are given radius. We don't need to take half of it. So we are given this number that we are going to use in the formula directly. So that we just use the 17 directly. So this equals pi times 17 square. And actually it's very simple, you can see that. So pi times 17 square equals, so I got 907.920. So round to the 2 decimal place. So 907.92. We still have yards as the units, square yards. So this is the second example. Now the third one, still area of a circle, but this time our answer should be in square feet. That's required. This circle has a unit, has a radius of 15 inches. So R here, 15 inches. Run to the 100th place, just like the previous tool. Now, let's say we are given the measurement radius in inches, but we are required that the final answer in square feet. That means our inch has to be converted to feet. So let's do that. 15 inches, we all learn how to do unit conversion. So we need to cancel inch, we need to get feet, and the relation is 1 feet and foot equal to 12 inches. So basically, we need to use 15 divided by 12, which is 1.25. Let's try that, make sure it's right. 15 divided by 12. Yeah, 1.25. So we get 1.25 feet. Now, this is the number we are going to use in our calculation. So area of a circle equals pi times r squared. So we get our r, which is 1.25 feet square. So now we just need to do the calculation part. Pi times 1.25 square. We get 4.908. And we need to run to the second decimal place. This is bigger than 5. Even 5, we need to run this up. So 4.91 square feet. That's correct unit. Now, let's look at our second page. We have 2 pages for this video. Our next example is to find the area of this triangle. This is a demonstration of a formula. So when you calculate the area of a triangle, you need to use this formula, half times base times height. The reason I display this formula first before we look at the example is that this base and the height have to be perpendicular to each other. It's not just a number for B, a number for H. So this is the base, this is the height. They have to be perpendicular. Now look at the problem we're going to solve. Apparently this is B, this is H. They are perpendicular. So area equals half times base, which is 16, times height, which is 13. So let's do the calculation. Half times 16 is 8. 8 times 13, that's 104. Let's try 8 times 13 equals 104. So we get 104. What's the unit? Feet, square feet. This is a unit for the area. So this is square feet. Now, the next one. Apparently, this shape is called trapezoid, right? In a four-sided figure, you have one pair of opposite sides that are parallel, and the other two sides are not parallel. So this is the trapezoid. Actually, we don't require the other pair to be parallel as long as you have four-sided figure with one pair of opposite sides parallel. It is called a trapezoid. Okay, now the formula for the area of trapezoid, half of this the sum of these two parallel sides. This one is labeled as A, one is labeled as B. Doesn't matter which one is which. Times the height. Height is the distance between these two parallel sides. So now we can plug in numbers. Half of 7.6 plus 20 times height is 13. So apparently in this particular example, you can see we don't use these two numbers, right? And that is why we need to understand the formula. You don't have to use all of the numbers given. Now let's do the calculation. This is what I'm going to do. I add this two together. Apparently that is 27.6, then times 13. Whenever you multiply by half, it's equivalent to divided by 2. So I'm going to multiply these two together and then divide by 2, or you use 0.5, multiply this number, then multiply this number. Either way is okay. So 27.6 times 13 divided by 2. I got 179.4. It didn't mention rounding. If we round to one decimal digit, that will be it. If we round the whole number, it will be 179. If we round to second decimal digit, even though we don't have one, we will write 40. So this is a kilometer square. Now, the next one is the last one for this part. Now we are looking for the area of this shape. Apparently, we don't have a formula for this particular shape. We call it irregular shape because we don't have a fixed formula for that. So whenever this happens, you want to do a strategy, which is called divide and conquer. You want to divide this figure into different shapes, different components, so that each component is a regular shape where you have you can apply a formula. So in example, I can imagine a line in here so that I have a small rectangle and a bigger rectangle. We calculate the areas of these two rectangles, then we add them together afterwards. Or you can say, for example, you draw a line in here. Now you form another scenario. You have horizontal rectangle, you have this rectangle. Again, we calculate the area for each of these rectangles, then we add them together. So we have a different strategy. We can even do it the other way, third way. Imagine we calculate the area of this big rectangle. Then we calculate this area of the small rectangle. Then we subtract this from this whole thing. You still get the same area. Again, logic is more important than steps. So let's stay with this one. I'm going to calculate the area of this horizontal rectangle, then this vertical one, then add them together. So let's say we need length times width. Length is A, width is D for this horizontal one. So horizontal rectangle area equals, this is A times D, right? Length times width. A is 30. D is 4, so that's 120 square meters. So make sure you pay attention to the units. If they don't have same unit, you convert them to the same units before you do calculation. Now I'm ready to do the vertical one, right? So vertical area, length, width. Length is C. It doesn't matter which one you call length and width. Length doesn't have to be longer than the width. The reason is eventually these two numbers multiply together. In multiplication, you all know that order doesn't make any difference. 2 times 5 equals 5 times 2, right? Which I will call length or width doesn't make any difference. So I just call C as the length. Now what is our width? Our width is this part, right? But we are not given that part. But this part equals this whole thing here. Subtract this part. So let's see. This is a B. Whole thing is B. Whole thing labeled as B. And this side is labeled as, oh no, I don't need that side. I'm solving for this side. This whole thing is labeled as B. This D is given, is 4. So let's label that. This B is 20. So basically, I use this B, subtract D to get this portion. That's our width. Okay. So in the end, we have C times B minus D, because the C is our length, and B subtract D, this is D, will be our width. So plug in numbers, and C equals 12, Then B is 20 minus D, which is 4. Go to the calculation, 12 times, this is 16. What do we get? 192. 12 times, oh, what happened on the calculator? 12 times 16, 192. We get a nice whole number. The unit is meter, so we're going to meter square meters. Okay, this is the area examples. Next video, we're going to do several examples for the volume.